Hi students, today in this lecture we discussing the topic is convolution theorem. So this is one of the important theorem to find inverse Laplace transformation. Okay, so first of all see the statement here. So let f of t and g of t be two functions and L inverse of f of s is equal to f of t and L inverse of g of s is equal to g of t, and here given inverse property. So f of s and g of s inverse Laplace transformation is equal to f of t and g of t respectively. So then L inverse of f of s into g of s is equal to integration 0 to t f of x into g of t minus x into dx is equal to f star g. So this is a convolution definition of two functions f and g. So and this is also convolution is equal to the L inverse of f of s into g of s. That means to finding inverse Laplace transformation of the product of the two functions. So product of the two functions means here f of s and g of s. And given any function, first of all separating two functions. So separating two functions means compulsory. We know that the L inverse of the two functions compulsory. We know. Okay, then finding product of the L inverse. So using this property, this formula. Okay. So f of x means here L inverse of f of s, and g of t minus x means L inverse of g of s and g of t place lo t minus x replace cheyali. Okay na? So this is the convolution theorem, and where f star g is called to convolution of f of t and g of t. And note here f star g is equal to g star f, and we can changing the two functions, we getting also same resultant, and f star g is equal to g star f is also both are always equal. Okay, so see the example here. Yeah, use convolution theorem to find inverse Laplace transformation of s by s square plus a square whole square. Okay, so see that assumption, let L inverse of s by s square plus a square whole square is equal to L inverse of, this is the separating the two functions. Okay na, s by s square plus a square into 1 by s square plus a square. So assumption this is f of s and this is g of s. Okay na, product of the two functions. So that is equal to here, first finding f of s and g of s. Next finding L inverse of f of s. L inverse of s by s square plus a square and L inverse of g of s is equal to L inverse of 1 by s square plus a square. So which is equal to cos at, and which is equal to 1 by a into sin at. So this is a function is f of t. Okay, this is a function is g of t. Okay. So now we are using the convolution theorem is L inverse of f of s into g of s is equal to integration 0 to t f of x into g of t minus x into dx, that is equal to f star g. Now substituting the two values f of x and g of x. Okay, so that is equal to L inverse of s by s square plus a square into 1 by s square plus a square is equal to integration 0 to t. So f of x means cos ax. Okay, next g of t minus x means this is g of t plus lo t minus x, 1 by a into sin of a into t minus x into dx. Now finding the integration this one. Okay, now continuation. So that is equal 1 by 2a. So now dividing multiply with 2 only, because sin a cos b form, there's 2 sin a cos b form, and dividing multiply with 2. So that is equal 1 by 2a into integration 0 to t, 2 sin a cos b means sin a plus b. The sin of at minus ax plus sin a minus b, sin of at minus ax, that is equal simplification. So ax is a cancel, sin at plus sin of at minus 2ax into dx. Now integration here 1 by 2a into sin at is a constant, so integration of 1 x. So next is sin of at minus 2x means integration of sin means cos at minus 2x, and take x coefficient here 2a, so by 2a. So limit 0 to t. Now substituting upper limit 1 by 2a into x is equal to t into sin at plus 1 by 2a into cos of at minus 2at, and cos of minus at means cos at. Lower limit, so this is x is equal to 0, 0. Next ఇక్కడ minus 1 by 2a into cos at. So this is cos at is a cancel. So that is equal to t by 2a into sin at. So therefore inverse Laplace transformation of s by s square plus a square whole square is equal to formula t by 2a into sin at. Okay, this is the required result. So next one, next example here, use convolution theorem to find the L inverse of s square by s square plus a square whole square. So assumption here, product of the two functions. So this is f of s and this is the g of s. That is equal to here f of s and g of s. Now finding L inverse on both sides. So that is L inverse of f of s is equal to L inverse of s by s square plus a square, and L inverse of g of s is equal to L inverse of s by s square plus a square. That is equal to cos at, and this is also cos at, same functions. So f of t and g of t by using convolution theorem. So this is a convolution theorem to finding L inverse of f of s into g of s, that is equal to L inverse of s by s square plus a square into s by s square plus a square is equal to integration 0 to t. This is f of x is equal to cos ax. So g of t minus x is equal to cos of a into t minus x into dx. So that is equal to cos a cos b form. There is no 2. So with dividing and multiply with 2. 1 by 2 into integration 0 to t to cos a t minus x into cos ax into dx. So that is equal to now continuation. So that is equal to 1 by 2 into 0 to t cos a plus b plus cos a minus b form only. 2 cos a cos b means cos a plus b plus cos a minus b. So cos of at minus ax plus cos of at minus of ax minus ax into dx. That is equal to 1 by 2 into integration 0 to t cos at, the cancel. So cos of at minus 2ax into dx. So now integration, so 1 by 2 into cos at is a constant, integration of 1 x into cos at. So cos of integration ki sine minus sine. So that is equal, cos ki integration sine. So ikkada minus 2a kada, coefficient minus 2a means minus 1 by 2a. Sine of at minus 2ax in from limit 0 to t substituting. So 1 by 2 into t into cos at. So ikkada, so sine of minus at here, sine of minus at minus into minus plus 1 by 2a into sine at. Okay, lower limit 0. So x is equal to 0 means 0. Ikkada minus of minus plus 1 by 2a into sine of at minus 0. So sine at. So this is both are same. So that is equal 1 by a. So 1 by a is a common. So that is 1 by 2a into at cos at plus sin at. So this is a required result. L inverse of s by s square plus a square whole square is equal to 1 by 2a into at cos at plus sin at. Okay, no? So next another example here, use convolution theorem to find the L inverse of 1 by s minus 1 into s plus 2. So that is equal to here product of the two functions. This is f of s and this is a g of s. Okay. Now finding L inverse of f of s is equal to L inverse of 1 by s minus 1, and L inverse of g of s is equal to L inverse of 1 by s plus 2. So 1 by s minus 1 L inverse e power t. This is f of t. So 1 by s plus 2 ki e power minus 2t. That is f of t and g of t. By using convolution theorem, this is a statement of convolution theorem. So L inverse of 1 by s minus 1 into 1 by s plus 2 integration 0 to t. So f of x is equal to e power x into g of t minus x is equal to e power minus 2 into t minus x dx. Okay, now finding the integration. So integration 0 to t. So ఇక్కడ simplification is e power x into ఇక్కడ e power plus 2x అంటే e power 3x. Next e power minus 2t. So e power minus 2t is a constant. Okay, now finding the integration of e power 3x. So that is equal to continuation. So e power minus 2t is a constant. Integration 0 to t e power 3x into dx. So integration e power minus 2t into e power 3x by 3 limit 0 to t. So that is equal to e power minus 2t into substituting the upper limit e power 3t by 3 minus e power 0 1 by 3. So this is the required inverse Laplace transformation of the given function. Okay. So that is equal to L inverse of 1 by s minus 1 into s plus 2 is equal to 1 by 3 into e power t minus e power minus 2t. Yeah, this is one of the important convolution theorem. Okay, for more videos please do subscribe my channel, like and share it. Thank you.